Hey everybody, welcome to the video. Let's simulate an inverting amplifier using LTspice. So let's start a new file here. I'm going to add an op amp. So right here, add a component. There's a group here called op amps right here. I'm just going to click that and look, there's like tons of them by different manufacturers. These are all models of actual products. There's a group here at the end that says universal op amp. You can use these for simulations, but they don't simulate all of the features. So careful using those. You actually want to choose one of these products from some manufacturer. Which one do you pick? I recognize this one personally, the AD8066. I've used it before to build headphone amplifiers. So it's pretty good. So I know it's a real product that works. So you could go on ahead and use the same one I'm going to use. So this, just plop that down there. Okay, so we got an op amp. And when you use an op amp, you always want feedback, right? So I'm going to add a resistor here, and I'm going to wire the output back through this resistor to the input. Which input? The minus or the plus? So just think to yourself, you're trying to subtract out some kind of error. So that's kind of a mnemonic device to remember. Subtract some kind of error. So the feedback goes to the minus, the inverting input. Okay, so here we go. We have a op amp with feedback. Now, if you want to design an inverting amplifier, your input signal would go to the inverting input, the minus. If you want to build a non-inverting amplifier, the input signal would go here to the non-inverting input. So just keep that in mind also. And we can control the amount of signal that gets there by using a resistor. Right, so for this lab, we want to simulate an inverting amplifier. So I'm going to wire the input to the minus, right, the inverting input. Okay, and we just need some kind of voltage input. So I'm going to add a voltage source. I'm just typing voltage. There we go. Okay, let me wire that in. And this needs to tie to ground. So right here is my ground. Wire that. And the op amp's job is basically to make these two voltages match. So I'm going to tie this one to ground also. Okay, almost done. We still need our supply voltages, right? It needs a positive voltage supply and a negative voltage supply. How do you build that? So I'm just going to drop two more voltage sources there. Okay, and let's just give it values so we have something to talk about. So I'm right-clicking. I'll just type 12. 12. I got two 12-volt supplies. Now, take a look at this. Let me get the pointer and okay, right? The top side here is 12 volts higher than the bottom side here. Or you could say the bottom side is 12 volts lower than the top side. So keep that in mind. If I were to stick a ground, let's say right here, right, then that's 0 volts, which means up here is 12 volts higher than 0. Right, so this is positive 12 volts, which I can wire to my positive supply pin. Now, check this out. If I wire the ground here, right, where's my little hand, right? So up here is 0 volts, and down here is 12 volts lower than 0 volts. So it's actually negative 12 right here. So I can take this negative 12 and wire it to the negative supply pin right here. Right, so we have positive 12 up here, negative 12 over here. Okay, now let's just finish putting some values in here. So let's say this resistor is 1K And over here, I'll right click and I'll just call this 3K. So I'm expecting a gain of 3 right here. Okay, now for the voltage input, let me right click. I'm going to click advanced, and I'm just going to give a sine wave. Okay, and let's say the amplitude is 2 and a frequency of kilohertz. Right, so what does this mean? It means it's waving between positive and negative 2. But if I were to add some kind of DC offset here, let's say 1 volt, then it's actually going to be plus or minus 2 plus 1, right? So it's going to be going between negative 1 and positive 3. So you can adjust these based on whatever situation. Okay, so let's just show that. I think we're ready to run a simulation, so I'm going to click here, run. Let's see, what did I set the sine wave? 1 kilohertz. So let's just run it for a few milliseconds. 3. All right. Now, if you, right down here, over here, you move your cursor around, this voltage probe pops up. So I'm just going to click right here. Right, so I just put a probe right where our input voltage is, and here it is. It's a sine wave. If I click right here, you see here, it brings up this window, and see this cursor? If you put your mouse right where this is here, you can drag this around. Right, so at the bottom here, it's about -1, and I'm dragging up here, it's positive 3, just as we expected. Right, and now I'm back down here. I'm going to add another probe to, where is the output? Right here. This is the output right here. There we go. Okay, so kind of as expected, the output, the blue one, is inverted from the input, and there's some amount of gain, right? So right where the, let's see if you can see my cursor, right where the green input here is at positive 3, the blue output here is at -9. And then here, where the green input is at -1, the blue output is at positive 3. Right, so basically a gain of -3. All right, but let's talk about these supplies. So if I'm back down here, I'm going to right click here. Let's say this is 5 and 5. So I just changed my supply to plus or minus 5. Let me rerun the simulation. Oh, look what happened over here. Right, so we were expecting some kind of signal here of like -9, right? But what are we getting? We can click here, and if you want to actually look at the number, right? So we're getting -5 because your output voltage can never exceed your supplies, right? And I'm supplying plus or minus 5. Let's see. Let's say I change the gain to even more. Let's say 4. Rerun this. And even more. 6. Rerun it. Look, so both the top and the bottom, right, got saturated, right? And they're kind of capped at plus or minus 5 because of our supplies. So as an engineer, you have to be careful to provide enough supply voltage based on the output you're expecting for your circuit. Right? So very important to remember this concept of saturation. Right? So give this a try for yourself. Let me know if you have questions. I'll see you in the next video.